Welcome to the Medicinal Herbs podcast from the Holistic Matters podcast series. In this episode, Professor Kerry Bone returns to talk with our host Sara Le Brun-Blashka about Nrf2, also known as Nrf2, and the ARE response. Kerry and Sara discuss the health benefits of priming the Nrf2 pathway, including the role played by mitochondria and the best herbs for supporting the Nrf2 response.
We're excited to have Kerry back with us today, having this discussion about Nrf2, as we in America say it. Kerry, can you give us a little bit of a definition about Nrf2 and ARE? First of all, maybe define those two topics and what they are, and then how do they have a response in the body?
Okay, so Nrf2, that's new to me. Nrf2 is, of course, how I refer to it. In its full name, it's called the Keep 1 Nrf2 ARE response. Now, for those of you who are a bit nerdy, they're all meaningless except for the last one. Keep 1 stands for couch-like ECH-associated protein 1. And Nrf2, now you need to be careful. There are two Nrf2s, and I've even seen them confused in the literature. So one is related to mitochondrial function, and it's usually, big N, big R, big F2. And this is what I'm talking about now is big N, little r, little f2. And that's called nuclear factor E2, related factor 2. Then we have the final thing, which is the antioxidant response element, ARE. So keep 1 Nrf2 ARE, and it's abbreviated. We just call it for simplicity the Nrf2 pathway, or as I've just learned, the Nrf2 pathway. So what is it basically? It's a cellular response, and it's a cellular response to what we can call toxic or oxidative stress. The chemicals that trigger this response are known as electrophiles, which means literally electron lovers. So they want to grab electrons wherever they are. And of course, that's potentially damaging for the cell. And anything that is electrophilic, that loves electrons, of course, is an oxidant. So hence the name antioxidant response element, ARE. But there's so much more to it. Absolutely so much more. It is a fundamental response of cellular protection that has so many layers. But in its essence, what happens is that when the cell is being stressed by electrophiles, there's a sensing chemical called KEAP1. And the KEAP1 is normally tethered in the cytoplasm of the cell. So when the cell is under this sort of stress, and it's a milder stress response. So the Nrf2 response, if you like, is the step before an inflammatory response. And if you've got a healthy Nrf2 response, you can lower your tendency to generate unneeded inflammation. So the KEAP1 is being tethered in the cell cytoplasm, but under this stress of electrophiles, of toxins and oxidants, that tethering weakens. And when the cell comes under oxidative or toxic stress, that bond between the KEAP1 and the Nrf2 is weakened. And the Nrf2 then migrates away from the cytoplasm, gets activated as it migrates into the nucleus of the cell, where it latches onto the cell's DNA and literally induces the cell to produce hundreds of protective proteins. So Nrf2 is a nuclear transcription factor. It induces the nucleus of the cell to respond to this stress.
So that's, a very interesting aspect, because we're hit with toxins and other things all the time. So what's driven this obsession? I know I've heard you lecture many times on it. So what drives the obsession with this?
Well, it's three key things. The first is that the discovery of this response pathway fundamentally redefines our understanding about oxidative stress and about detoxification. That is the first thing. The second reason why I'm obsessed with it is that the things that seem to activate and prime the response, this pathway to make the responses more efficient, are generally plant chemicals, phytochemicals. So it's almost like, of course, they're working on drugs that work on this pathway. There's a lot of that research going on. But right now, the best information we have about things that help improve the efficiency of this pathway, I'll use the word prime, that prime this pathway, are plant chemicals. And then the third factor is that it has such far-reaching health impacts. It's fundamental now, I believe, to the treatment of so many conditions. I'd like to just talk about this redefining the first point I made, because I can elaborate on the others, but about redefining, if you like, the antioxidant debate or antioxidant discussion, and indeed toxicity. So let's start with the simpler one first. Okay, when I did my classes at college, I basically got the idea that it was your gut cells and your liver cells, and to a less extent your kidney cells, but mainly your liver cells were involved in phase 1, phase 2 detoxification, and that phase 2 enzymes, they were largely produced by the liver. So what the Nrf2 pathway shows us is that any cell that has a nucleus is capable of inducing phase 2 enzymes to protect itself. So it redefines detoxification, not just about the liver, but and of course you can help the liver by using agents that prime this pathway, but it redefines detoxification at a cellular level. That's the first point. And then the next point I'd make is that it redefines the whole discussion, as I've said, about antioxidation, antioxidative protection. So, we hear all the time, don't we? It's become a total cliche. It's become totally meaningless. People talk about, oh, this plant contains antioxidants. Most scientific journals now refuse to accept papers, submitted to them by researchers that show that plants are antioxidant. This herb is antioxidant. They all are. They're out there in ultraviolet light and all of those elements 24/7. Of course, they're full of antioxidant chemicals. But what we're dealing with is passive chemical antioxidation versus biological antioxidation. So, you can see in the past, people have played games about, with antioxidant measures like ORAC, my ORAC is bigger than yours. Hey, the ORAC of acai berries is 10 gazillion, and therefore it's the best That's all based on test tube assessed passive chemical antioxidation. And it's a completely meaningless concept, because the things that are antioxidant in a test tube are not necessarily antioxidant in the body. And what's more, with chemical antioxidation, you get just a passive blanket effect that can sometimes interfere with cell physiology, because oxidative elements generated by cells are used as part of normal healthy physiology. But the main thing is a lot of these so-called antioxidants that are measured by ORAC and other techniques. It's uncertain if they access the cell. It's uncertain if they cross into the brain. It's even uncertain that they might even cross the gut wall intact. Many plant chemicals, as we know, phytochemicals, are broken down by our gut flora. Also, this whole thing about passive, having antioxidants that then float around in your blood, exerting some sort of passive blanket effect on oxidation, it is meaningless, because such chemicals are readily depleted. They're probably not there in high enough quantities anyway. Now, contrast that with a biological antioxidant protection, which you get with the Nrf2 pathway. It's occurring inside the cell where it's needed, and it's compatible with cell physiology. It's only activated, switched on, switched off when it's needed. And the antioxidant factors that are produced, and that's just part of the Nrf2 response, are enzymatic. Superoxide dismutase, for example, SO2, catalase. So these enzymes, if you're catalytically exerting antioxidant activity, you can quench 10 billion free radicals per second. Mm-hmm. But if you look at one antioxidant phytochemical in the bloodstream, it can only quench one free radical. So you could see the power of invoking your biological antioxidation responses, which is the Nrf2 pathway, is enormous. It's just enormous.
I think one thing you said earlier that really kind of triggered something that I was thinking about is this idea of detoxification, right? Our cellular detoxification.
Yeah.
And then how it happens in the cell. It's not just the liver, it's a broader aspect, and the role then of the mitochondria as a whole. Can you talk a little bit more about that and how the cellular factor is really happening, and why is that so important to human health?
When we take it down to basics, we are fundamentally as healthy as our cellular health. Mm-hmm. So cells make tissues, tissues make organs, organs make systems, systems make the whole body. So underpinning it, the foundation of good health is cellular health. And what this pathway does is it gives us access to improving someone's cellular health. And I think that is just so fundamental. So if I may, perhaps if I could list at a biochemical level some of the core functions of activating this mm-hmm. pathway. So the first thing, as I mentioned, is many antioxidant enzymes are induced. So SOD, catalase, thioredoxin, glutathione peroxidases, glutathione reductase, glutathione transferase, for example, even some heat shock proteins. Mm-hmm. It also activates the synthesis of glutathione. So glutathione, of course, is fundamental to cellular antioxidant protection and against cellular toxicity prevention. Because, right. For example, if the cell is exposed to a heavy metal, the cell expends glutathione in dealing with that heavy metal toxic effect, and the glutathione will get depleted unless you've got a way to reactivate it. The next thing it does is it induces a range of key phase 2 enzymes, as I mentioned, like sulfotransferases and glucuronosyl transferases. So it basically improves our capacity for that important second step in detoxification, which is phase 2. It also upregulates heme oxygenase 1, which is a heat shock protein, and it's hugely important in nerve cell protection. And one of the reasons why they think ginkgo is so great, because ginkgo is an Nrf2 primer, why ginkgo is so great for the brain is via heme oxygenase 1. It also helps the toxic effects of iron overload, and it also upregulates at a cellular level your phase 3 transporter proteins. You're upregulating phase 2 to put things onto the toxin, to clear it out of the cell, and then you're upregulating the various proteins that transport that toxin outside the cell. And then finally, and one thing that really excites me about this, is you think, oh, isn't that just so amazing? Isn't that enough? But as the man says on the TV, there's more. There's more on offer here. And what's on offer is mitochondrial support. We probably in the past have thought about mitochondrial support and mitochondrial therapy in terms of, the various factors involved in mitochondrial health, be vitamins and, alpha lipoic acid and ubiquinol and those sorts of things, or ubiquinol, as you probably say. But And we haven't thought about herbs for mitochondrial health, but via this pathway, we can significantly impact and improve mitochondrial function.
So what herbs would you think are best to have that effect on the Nrf2 response?
Well, here you need to be careful because it is I guess, sensitive trigger mechanism of the cell. So again, if you create an artificial environment like a test tube experiment, you'll see lots of things triggering the Nrf2 pathway in test tubes. What I'm more interested in is what actually does it in, for example, animal models, and even more importantly, if it's been shown clinically. So that's why the things I recommend for priming this pathway is really based on the science, the clinical aspects, and at very worst, some lab animal models, but not test tube research. So I would, as I constantly do, caution our listeners to not make too much of test tube research. It has its value in certain applications, which I do flag when I talk about it. But for Nrf2, we at best, we want clinical. So what's been shown clinically to activate this pathway? Resveratrol, which is a very important phytochemical found in a plant called Polygonum cuspidatum, which has now been renamed as Fallopian and then got renamed again as Notria. So you take your pick about what you want to call that plant, but the phytochemical remains the same. It's resveratrol. And another important one is the various sulfur compounds in garlic. Ginkgo biloba has been shown to have good activity. Curcumin, again, there's some strong clinical data for curcumin that it activates this pathway. Green tea, grapeseed, things that were traditionally known as antioxidants, but we now know are much, much more powerful because they do biological antioxidation. And broccoli sprouts. Broccoli sprouts is another important one.
You didn't mention it, but rosemary also. How would you see rosemary?
Yes. Rosemary is from a remembrance, isn't it? So how come I didn't remember rosemary?
Right.
That's kind of crazy because rosemary is my favorite for this pathway. And the reason why is because they've discovered it has quite a unique chemistry. For those of you who know a bit of chemistry, the rosemary key phytochemicals, which are carnosol and carnosic acid that activate the Nrf2 pathway, can exist in a quinone form, a bit like coenzyme Q10, ubiquinol or ubiquinol as people call it. You can get this quinone form, and that's what actually primes the pathway. So this form of the rosemary phytochemicals only occurs in a tissue environment that's under oxidative stress. So then the rosemary carnosol and carnosic acid flip to the quinone form, and it's that quinone form that activates or primes the Nrf2 pathway. So it's so perfect because it's not even active until it gets into a tissue environment when it's needed, and then it switches on a response in the cell that only plays as it's needed. So it's perfect antioxidant protection because you're not interfering with vital cell pathways that sometimes do rely on oxidative elements and free radicals to maintain good cellular health. That's the problem with the passive antioxidant theory. It's been discredited because of that, but people haven't looked further to understand, well, no, it's not about chemical antioxidation, it's about biological. And to me, the perfect biological antioxidant, because of this reason, are the phytochemicals that are found in rosemary.
What about if we think more on foods and dietary phytonutrients? And we could make a good curry, Kerry, out of this too, maybe, right?
Yeah, curry's my alter ego, as we've now learned. I'm Kerry Bone. Yes, so there was a group at Harvard that did some very interesting research. And what they did was, and it plays into all the elements that are becoming our strength in terms of understanding health. So what they did was they gave some people, flavonoids that are found across the diet. And they looked at the metabolites of these flavonoids, because in the body now we understand there's actually a significant crosstalk between phytochemicals and our gut flora. So when I say crosstalk, what I mean is that phytochemicals can influence levels of gut flora, acting kind of like as a prebiotic. But as part of that prebiotic action, the phytochemical is changed into different chemical entities. Again, it's a reason why test tube research for things like flavonoids, for example, is not that meaningful in most cases. So these products of that crosstalk, that interaction of our gut flora with the phytochemicals, these products were then tested on Nrf2 pathway models and were found to be highly active. And in their discussion, the researchers put forward an important point, and that is that if you don't have enough phytochemicals in your diet, your Nrf2 pathway at a kind of evolutionary level will be subpar. So here we are with the modern Western diet, as it's called, which is phytonutrient or phytochemical deficient, in my view. And we're starting already behind the 8 ball because we don't have those phytonutrients in our diet, and our Nrf2 functioning is below what it should have been from 1,000 years ago, because our diets have changed, but our biochemistry hasn't adapted to that dietary change in a fundamental way. So my point is we can go 2 levels with this pathway. Get the right diet and you bring it up to at least a normal functioning level. It's subnormal with many diets, and then throw in things like rosemary and ginkgo and turmeric and what have you, and you optimize it to well above what you can get even from a healthy diet.
I personally have been looking into this whole concept of, phytonutrients and the microbiome and its role. And it's just such a fascinating concept, right? And I mean, why would we think that the microbiome wouldn't utilize those types of things? It's not just fiber, it was kind of a naivete, right, of the microbiome science, which is such, we're right at that precipice with it.
Yes,
to understand, yes. Right. It's so fascinating.
It's an emerging field, and we're gaining more and more knowledge all the time. And one thing that I've maintained for quite a while, and it's fully described and researched in chapter 2 of Principles and Practice of Phytotherapy, the chapter I did write that chapter, and it's that for many phytochemicals, you need good, healthy gut flora for them to be converted to the active form that actually exerts beneficial effects in the body. And so that's why when I was taught herbs, and I was taught in a traditional way, but by my teacher Heinz Zelstra, he was very forward looking and was a scientist and had a scientific perspective as well. We were always taught that the therapy, and don't forget, this was training as a pure herbalist, not as a natural therapist, just purely working with herbs, medical herbalists as they call them in the UK. A medical herbalist never just uses herbs; they always use diet as well. So diet plus herbs was the foundation of medical herbalism. And we now understand that's one good reason why. There are many other reasons why you look at diet, but that's one good reason why. So you get a healthy diet, you get the right gut flora, the herbs will work better in many cases.
Right. Yeah, it's a really emerging area, but it's interesting because it's really taking traditions and just the science is now meeting it, right?
That's right. That's right. Yeah, it's amazing how many aspects of tradition, are now being backed up by science. For example, if we take saffron, wonderful herb, Avicenna, the Persian physician, wrote about the benefits of saffron. I think, when was he, 10th, 11th century, something like that. And it was broad-ranging things, like the brain and reproductive function and vision and what have you. And you'd think you're looking at that, he's just, some delusional, person from the past who was ignorant and knew nothing. But in fact, every single one of those apparently unconnected and diverse attributes of benefits of saffron that Avicenna was saying it possessed has been verified by scientific research,
Right.
including clinical research. So yeah, in many cases, we're just validating the past.
Exactly. So if we think about, this diet and then doing additional, medical herbs, where can we have too much? Where is that breaking point, or is there a breaking point?
Okay, so look, there's only one circumstance where I think you don't do this pathway.
Mm-hmm.
And that's when someone has a malignant tumor, they have cancer, and conventional techniques are being used to kill that cancer. You want the cancer cells to die, obviously. If someone's having chemo or radiotherapy, you don't want to help the cancer cells survive. Now, we don't know for sure, but one reason why cancer cells can survive chemotherapy and radiotherapy so well and other treatments so well is because they upregulate this pathway constitutively. So normally the Nrf2 pathway is an on-off switch. In cancer cells, that switch is on the whole time. Mm-hmm. So as I said, we don't know. If we give these herbs during chemo and radiotherapy, and I want to stress these herbs are actually vital and needed at other times, but with someone with cancer, but if we give these herbs during chemo and radiotherapy, are we helping the cancer cell to survive, or is the switch fully on and it's at 10 and you can't turn it to 11 with these herbs? We don't know, but we need to exercise caution here. And so around chemotherapy, and radiotherapy, at least 2 days before, day of, and 2 days after, generally I recommend that we do not give these herbs.
As we kind of wrap everything up, I always like to have this clinical pearl. So what would be the clinical pearl to implement in practice when we're thinking about the Nrf2 AR pathway response in a clinic? What does that look like for a practitioner?
It's not something I can just translate into one thing. But to me, the benefits are so broad. But I think the one thing to take home would be this, and that is, this is mitochondrial therapy. This is the fundamental basis of mitochondrial therapy. You can improve the health of the mitochondria. You can protect the mitochondria because mitochondrial DNA is very exposed to oxidative damage. And there's you can even improve. It's been shown to improve mitochondrial dynamics because we now know that mitochondria are highly dynamic, and that mitochondrial dynamics is vital for cellular health. If you want to boost someone's mitochondrial activity and you're giving them this supplement and that supplement as substrates, you must do this. It's like, I use the analogy, I've used it before, it's like brick and bricklayer. The substrates will give you the bricks, but you need the big bricklayer to build the wall from those substrates. And by priming this pathway, you can do that on mitochondria. So that's the first pearl. The second pearl is you must do this pathway for detox. You must prime this pathway. And the beauty is that most of the herbs that we use for detoxification do actually detox this pathway. So it works in that way, that we're doing it already, but nonetheless, it's a good area to focus on those, garlic, curcumin, rosemary, green tea, all of these things that improve detoxification seem to prime this pathway. Perhaps the one exception is Schisandra, that detoxifies for different reasons, but certainly all the other herbs do that. And then healthy aging and longevity. This should be part of any healthy aging and longevity program. Together with my microcirculation diet, it's good for the eyes. And together with my microcirculation diet, it's good for brain health. So neuroprotection is really key important aspect of this pathway. I think, look, there are others, and I have got a whole chapter devoted to this pathway in my forthcoming book, and I'm hoping in our next podcast we can talk about my book.
I know, I can't wait to hear about the
Yes.
upcoming edition and all the new information that you're adding to it. It's very exciting.
And naturally, with my obsession with this pathway, I have, included this. Just coming back to longevity, it's been, they used to wonder about short and long-lived species of animals, within the same genus, like bats, for example. Why do some bats live very, very long and some bats live not so long? And they thought, it's because of the amount of oxidative damage that they get. Well, that's now been thrown out. And what they actually believe it's due to is the amount of antioxidant protection they have. And that's not this passive antioxidant protection via ORAC values. It's their efficiency and responsiveness of their Nrf2 ARE pathway. So they've actually been able to show that long-lived species of animals have better Nrf2 levels, have lower keep levels, so that keep 1 levels, so their Nrf2 is more responsive, that the nuclei of the cells in these animals are better able to bind Nrf2, and that the downstream responses, the proteins that are made from that Nrf2 nuclear binding, is more efficient. So the efficiency and level of your Nrf2 pathway, at least in these cross-species studies, seems to impact longevity. And that, to me, is a discussion that I think everyone needs to consider, because we hear a lot about this, take this, do this, live longer, all of that sort of stuff. But let's take it down to the cellular level, and this pathway is so important for that. I mean, some people have described it as the most significant medical discovery in the last 20, 30 years. I think that's an exaggeration, but it is quite significant. But what makes it more significant to people like ourselves is that we own the space. We alone have the proven agents to prime this pathway.
Well, I think everybody wants longevity, right? And if the Nrf2 has that opportunity, we're really wanting to focus on that. And health and wellness, it's so involved in our everyday lives. And even though we don't think about it, our cells are, being affected by it, and then produces this great opportunity for us to be healthy and to live longer and, have vibrant lives.
Well, absolutely. So scientists are now, the concept was first proposed in 2005, and now it has considerable momentum, although we still need to understand it fully. But scientists are talking about this concept of the expososome. So, you go back to 100 years from now, maybe 120 years, you look at things like microplastics, glyphosate, heavy metals were there, but they're the only ones that were. But pesticides, herbicides, all of that sort of stuff. Plasticizers, flame retardants, all of those things. We were just not exposed to them now, and people who are in these industries say, "Oh, look, we've got the tests, and the levels are so low. It's not going to cause any health problems here. We've given it to rats and blah, blah, blah." But what the expososome concept is saying, no. You cannot look at a single exposure in isolation. You must look at the total exposure that a person experiences from various sources in their lifetime. And that's what's going to impact on health. So it's that chemical cocktail, and indeed that environmental cocktail, that we are exposed to. So my point here is that more than ever do we need to be priming this pathway. So understanding, to me, of this Nrf2 ARE pathway has come at just the right time, where we are in human history, with the multitude of low level but combined, who knows, chemical exposures that we are experiencing.
This is so important, and the wisdom that you've shared with us today is really helpful for every practitioner who's listening. And I want to thank you for this discussion.
Yes, thanks, Sarah. It's been wonderful to talk to you yet again. I'm looking forward to the next time.
Perfect.
Thank you, Kerry, for joining us today to talk about Nrf2, the importance of dietary phytonutrients in the form of food and medicinal herbs, and applying the science of the Nrf2 and ARE response in the clinic. For more on herbal medicinals and other components of holistic healthcare, go to WholisticMatters.com. That's holistic with a W.